In the last lesson, we solved polynomial equations by factoring, but actually there are some polynomial functions such as f of x equals x cubed minus 2x squared minus 5x plus 6 that are not factorable. So we do have another method that we can use to solve our polynomial equations, and that's with that synthetic division. Let's just look at that example for a minute. It's got 4 terms, so I might consider doing grouping. In the first set, I could maybe pull out a GCF of x squared and have x minus 2 left over. But let's look at that second set of parentheses. There is no GCF, and there's no way I'm going to be able to manipulate it so that it becomes x minus 2. So it's simply not factorable. In the past, when we were working with quadratics, we could then use the quadratic formula for such a case, but we're solving these polynomial equations that aren't necessarily quadratics anymore. So we're going to use synthetic division to help us find those zeros. And remember, our zeros are those x-intercepts, and they can also be called the roots. And once we use synthetic division, we'll use the quotient that we get and then factor or use the quadratic formula to finish up solving. Our steps listed here, we're going to use that given factor. Now, there's 2 ways they might give it to us: as a factor, which might be x plus or minus the number in those parentheses there. That's a factor. Or they might give us the root, which is going to be x equals the number. Remember, that's going to be inverse there. So if I have x plus 3 as my factor, my root would be negative 3. And so those are 2 different ways we'll get that information to complete our synthetic division. And then step 2, we'll use factoring or the quadratic formula. I do have the quadratic formula listed over here. Recall, it is negative b plus or minus the square root of b squared minus 4ac all over 2a. It is not on our reference sheet. It can be so helpful for you in those solving scenarios, so it is worth memorizing before our EOC. So let's look at number 1. It says if f of x equals x cubed plus 2x squared minus 19x minus 20, and x plus 1 is a factor. I'm going to go ahead and put parentheses around that. That is our given factor that we already know of that polynomial. Find all the zeros, those roots, the solutions, those x-intercepts of f of x algebraically. So let's use that factor that was given. That means if I set that equal to 0 and solve, negative 1 would be the root x-intercept 0. Okay, so using negative 1, we plug that in for our synthetic division. I'm going to put that in my little box. I'm going to go ahead and label for each of my terms here, x cubed, x squared, x, and constant, just making sure we don't have any missing terms to put zeros in. For x cubed, there's an understood 1, 2x squared minus 19x minus 20. That first term, the 1, is going to always come straight down. Multiply with my box, getting negative 1. Add straight down gives me positive 1. Multiply again with the box. 1 times negative 1 is another negative 1. Adding straight down, negative 20. Multiplying with the box, I get positive 20 for my last line here. And adding straight down, I get 0. Now, remember, this last part is our remainder. And I got 0, which means it is a factor. You should get 0 here every time. They're not lying to us in the problem when they say x plus 1 is a factor. So you should always get 0 here, or go back and check your work. Okay, so make sure you always get a 0 there. That is good and happy. All right, our remaining polynomial, our quotient here, always 1 degree less. So we have x squared, x, and our constant. We have a 1x squared plus 1x minus 20 is our remaining polynomial. So we've already peeled away a layer using this synthetic division. So now let's factor. So I'm going to slide over here. Let's do x squared plus x minus 20 is where I'm going to factor over here. We're going to look for the factors of negative 20 that add up to this understood positive 1. So 1 and 20, 2 and 10, it's probably 4 and 5. We would need a negative 4 with a positive 5. Those are my 2 magic numbers. Let's build those factors, x minus 4 times x plus 5. And finish solving. We're going to set each of those equal to 0 and solve. x minus 4 as a factor, when I solve it, the 0 or root there is positive 4. X plus 5, when I solve and subtract 5 from both sides, we're going to get a negative 5. So to answer our question, we were asked to find those zeros. They are 4, negative 5, and there's one more, there's 3. What was given? We were told that negative 1 was also a root or 0. So I'm going to note here, this was our given value in our problem. It is still one of our zeros or roots. If we were to graph this polynomial, it would cross our x-axis at that negative 1, just like they told us. One last thing I want to show you. Those are our 3 answers. We are done. 3 answers. Did you notice the degree of our polynomial was cubed? So if you have a degree of 3, you should have 3 solutions. This is a great test taking tool when we're using multiple choice on benchmarks or on EOC. Okay, so final answer for number 1, those zeros, roots, x-intercepts, however you want to call them, were 4, negative 5, and negative 1, not forgetting the negative 1 that was provided in the problem. Let's try again with number 2. It says if f of x equals x to the 4th minus 3x squared plus 2, and f of negative 1 equals 0, then find all those zeros of f of x algebraically. This right here, f of negative 1, that's telling us that root 0 x-intercept. It's saying when x equals negative 1, y is equal to 0. So think about your coordinate plane. When x is negative 1, the y is 0. It's sitting right there on that x-axis. Negative 1 is our root x-intercept 0. That is the piece I'm going to plug in for my synthetic division. So using a negative 1 in my tiny little box, we have x to the 4th, x cubed should be there, x squared and x should be there, and constant. So we've got 2 0 placeholders we need to make sure to include here. We've got 1, 0, negative 3, 0, and 2. Bringing down the first coefficient every time, 1 coming straight down, multiplying with my box, negative 1, adding straight down, get a negative 1, multiply with the box gives us positive 1, adding straight down, negative 2, multiply with my box gives us positive 2, adding straight down is 2, multiplying with the box, here we go, negative 2, adding straight down, there is 0. I should get r, or a remainder of 0, every time. They're not lying in the problem when they say negative 1 is the root or 0. So that all checks out. I'm ready to rock and roll. Our quotient here, final answer from our synthetic division, we have 1x cubed minus x squared minus 2x plus 2. Remember, your answer is always 1 degree smaller, and we just work our way down. So now let's factor. I'm going to bring it over here. X cubed minus x squared minus 2x plus 2. 4 terms. Let's use grouping. Make a note here on our notes. So grouping first half and second half together. That first half GCF is an x squared. Leaves me with an x minus 1. Second set of parentheses, GCF could be a negative 2. Leaving me with x minus 1. Now my parentheses are matching, so I know my factorization is going well. X squared minus 2 is my first factor. X minus 1 is my second. Let's solve them. Set them equal to 0. Solving that first one, adding 2 to the other side, I will get x squared equals 2. Now, remember, you can undo a squared with a square root. Those are inverse operations. So let's square root both sides. X equals, now when you take the square root in your solving process, make sure to include plus or minus the square root of 2. So there are 2 solutions there already. On the other one, I would add 1 to the other side. Really simple. Solving on this second factor, x equals positive 1. So our solutions, those zeros, listing them out, we had a positive square root of 2, a negative square root of 2, positive 1, and don't forget the given value, negative 1. Again, noting here on the notes, that was given in the problem. What degree did we have of our polynomial? X to the 4th. A 4th degree polynomial should have 4 answers, and we do see that. Degree of 4, 4 solutions. Moving on to our last problem, if f of x equals 4x cubed minus 28x squared plus 21x plus 18, and f of 6 equals 0, then find all the zeros of f of x algebraically. So again, given this root or x-intercept, this says when x is 6, the y is 0. So 6 is a 0 or root or x-intercept given information there. So let's plug in 6 to our synthetic division to help peel away a layer from our polynomial. Labeling, make sure we're not missing any terms here. No, we are not. We've got 4, negative 28, 21, and 18. Bringing down our first term, the 4, multiplying it with the box, we get 24. Adding straight down, negative 4. Multiplying with the box again, getting negative 24 this time. Adding straight down gives me negative 3. Multiplying with the box, there it is, golden. I'm getting negative 18. Adding straight down, there's that 0 for my remainder. I should always get that because they gave me a legit factor or root in the problem every time. Our final solution from our synthetic division, our quotient here is 4x squared minus 4x minus 3. So now factor. I'm also going to model on this one. What if you want to use the quadratic formula? Okay, so I'll do that on the right side. So let's try factoring this one first. 4x squared minus 4x minus 3. Now this one has a leading coefficient, unlike we saw in number 1. So remember, you're going to need to multiply the front and the back together. We're looking for the factors of negative 12 that add up to that middle term, negative 4. And we're going to split that center term to make it 4 to use grouping. So probably not 1 and 12. Let's do 2 and 6. Positive 2 with a negative 6, I think, is going to get me what I need there. So let's split up the middle here. I'm going to do 4x squared minus 6x plus 2x minus 3. I'm not sure if that's the best choice, but I think it's going to work just fine. GCF of the first group, I could do a 2x and have 2x minus 3 left over. All right, second one, let's do a 1 as our GCF, so then my parentheses match. Bringing my final factorization together, we got 2x plus 1 and 2x minus 3 as our factors. We're going to solve those, setting them equal to 0 and solving those baby equations. I would need to subtract 1 to the other side, so 2x equals negative 1. Divide both sides by 2. First 0 solution here that we have is negative 1/2. On the other factor, I would add 3 to the other side, getting 2x equals 3, and dividing both sides by 2. We have x equals 3/2 or 1.5 there. So there are our zeros. Now let's also model that you could use quadratic formula. Some of you don't like factoring, so you can always use quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, not on our reference sheet. If you're going to use it, you're going to need to memorize it. In our polynomial, looking over here on our work, our a value was 4, b is negative 4, and c is negative 3. So let's plug that in. A negative 4, so negative b plus or minus the square root of negative 4 is going to get squared, minus 4a and c all over 2a. So got that all plugged in. Let me clean it up a little bit. Those two negatives make a positive 4 plus or minus the square root of negative 4 squared. Here should always be positive 16. Negative 4 times negative 3, multiplying these three pieces together gives us 48 over 2 times 4 is 8. So cleaning it up again, 4 plus or minus 16 plus 48 gives us 64, loving the way this is coming out. So we have 4. I'm going to go ahead and split this up. So 4 plus the square root of 64 is an 8 over 8. And then we'll also have 4 minus 8 over 8. Just splitting up that plus and minus symbol there. So 4 plus 8 is 12 over 8. And then I can reduce that down to 3 over 2. 4 minus 8 is negative 4 over 8 or negative 1/2. Did we get the same things? Absolutely. All right, so let's go back and list out all of our zeros. I'm going to do that up here at the top. Our answers, we got a negative 1/2, 3/2, and what was our given? Let's not forget that piece. 6. Going to label. That last one was given to us in our problem. We had, look, our polynomial was cubic or a third degree. So there are 3 solutions. Great way to check. Degree of 3, 3 solutions. So it's definitely up to you how you want to finish out your solving in that second step. You can use factoring or the quadratic formula like I modeled on that last problem. We're definitely using that synthetic division with the given information. They're either going to give you a factor written in parentheses. Do make sure you solve that and change that value. Like in number 1, the factor was x plus 1. Make sure you use a negative 1 in your synthetic division to complete that. But then our remaining polynomial after the synthetic division can be factored. Or if you're just not very good at factoring or you don't feel comfortable with factoring, you can always use that quadratic formula like I modeled in number 3. So use synthetic division to peel away the layer with the given information. Don't forget that given 0 that is provided in the problem when you answer it, and continue solving with factoring or quadratic formula. Guys, this is just pulling together a whole lot of stuff that we've studied. We reviewed quadratic formula, we reviewed factoring, we learned synthetic division. So everything is coming back together, and that's just the nature of mathematics. We just keep building and adding skills that we've learned previously. So if you are stuck or have questions, please make sure you speak to me so we can work on this together. I will see you in class, guys. Have a great day.